In this section, we will see the user local database, password types, privilege levels, RBAC, and line security. Let's talk first about the local user database. That is only a set of usernames and passwords stored within a network device. We need it because it provides appropriate authentication services when AAA servers are not available. The best practices to create one is using hard-to-guess passwords, always using a strong password encryption algorithm, and the command to create one is username. As an example, this device does not have a local user database yet, so we're going to create one. We're going to create two users. First, user admin 1 is going to get assigned this view known as admin. We're going to talk more about views later on when we talk about RBAC. The second user is admin 2 that gets assigned a privilege level of 15. We are going to talk about privilege levels later on, and we are using a hard-to-guess password, but we are not using an encryption algorithm for this password. That is why we're receiving this warning. We're going to talk about encryption algorithms for passwords now. We need to encrypt our passwords since our passwords are stored within configuration files, and we need to prevent the case where a third party gets access to these configuration files. Over time, Cisco has provided several password types. Most of them include an encryption algorithm. Let's talk about them. First of all, we have type 0 passwords, also known as clear text passwords. These are not encrypted, so avoid these at all costs. Next, we have type 7 passwords that are enabled when we use the command service password encryption. This service will look for type 0 passwords and it will turn them into type 7 passwords using the VGNR algorithm. That is easy to crack. Although it is better than nothing, we should not use it anymore. Next, we have type 5 passwords that use an algorithm based on MD5. This algorithm is better than 0, than 7. However, a crack exists for this algorithm, so we should not use it anymore. It is actually deprecated in recent versions of iOS XE. Next, we have type 6 passwords that use an algorithm based on AES 128. It is recommended to be used nowadays. It is reversible. We can get the original password back as long as we know the password encryption key. We require more configuration in order to use it. Next, we have type 8 passwords that are recommended to be used nowadays. They are based on an algorithm known as password-based key derivation function 2SHA-256. This is the command. Finally, we have type 9 passwords. They are recommended to be used nowadays. Type 9 is the default for several Cisco commands. Type 9 uses the script algorithm, and this is an example of how to use it. Let's do a type 0 lab. We are going to create a user without any type of encryption, and if we see the configuration, we will see that we can see the password as is. Now let's do a type 7 lab. We are going to enable service password encryption, and we will see that the password was turned into a type 7 password with this weak encryption. This encryption algorithm is so weak that we can take this encrypted password into a decoder and we can retrieve the original password back. Okay, let's do a type 5 password lab. In this case, I am using an old iOS because type 5 passwords were supported back in the day. So I'm going to issue this command and see how it is encrypted. We see that it is using type 5. I'm going to take this encrypted password and I am going to try to enter it into a Catalyst 9000 for this user with this command. We see that the command is allowed to be entered. However, since type 5 passwords are deprecated, this user is going to get its password re-encrypted with a type 9 password. So let's do a type 6 example. We have these two users. Now let's configure type 6 and let's see what happens after that. These passwords are going to get automatically encrypted with type 6. After enabling type 6 passwords in the device, subsequent users that are configured with the default password type are going to receive type 6 passwords by default. In order to use password type 8, we use the parameter algorithm type SHA-256. In order to use password type 9, we are going to use the parameter algorithm type script. The enable commands also use password types for password encryption. In this case, we're going to execute enable secret and enable password to see what happens. In this case, enable secret uses type 9 passwords, and enable password in this case is going to use type 6 passwords because we have configured type 6 passwords previously. Next topic, privilege levels. First of all, what are privilege levels? They are a per-device local authorization database where a selective set of operational and configurational commands are organized on a per-level basis. So why do we need privilege levels? Because they provide authorization. Authorization improves network security and accountability. We guarantee having authorization even if the AAA servers are not reachable or if we don't have any AAA servers at all within the network. So we have 16 levels available. We have by default level 0, 1, and 15 pre-configured with default settings. Level 0 offers minimal set of commands. Level 1 offers a basic set of commands. It is also known as the user level exec. And level 15 provides access to everything. It is known as the enable level. In order to create our local authorization database, we may customize level 2 to 14. We may also customize level 0, but that is not recommended. We can configure a password for each level with the command enable secret, the level number, and the password. If we don't provide a level number, we are going to configure the password for level 15, so users may jump through levels as long as users know the target level password. If we want to enter another level or jump into it, so to speak, we must use the command enable and the level number. If we don't provide a level number, that means that we want to jump into level 15. If we wanted to jump from a higher level to a lower level, the password is not going to be required. Now, if we wanted to jump from a lower level to a higher level, if the higher level has a password, it is going to be required. Otherwise, the error no password set will be given. Before customizing levels, be aware that initially any level will have the same set of permissions as level 1. In order to grant permissions to a level to an operational command, we are going to use the command privilege exec, the level number, and the operational commands. Example of operational commands are ping, show, clear, reload, and so on. When granting permissions to a command to a level, there will be consequences. The levels that exist below the level are going to get denied access to that command, and the levels that exist above it are going to inherit access to that command. What happens if I grant permission to execute the same command to two different levels? In that case, the last command entered prevails. So in this example, this command will prevail and it will override this other command. An interesting thing happens when granting permissions to a level to a command that has parameters. In this example, level 11 will be granted permissions to execute not only show IP route, but show IP and show. This will have the net effect of denying all of these three commands to the levels that lie below level 11. At some point, you might want to start all over again assigning permissions for a certain command. In that case, you will issue privilege exec, reset, and then the name of the command. So this will erase any reference to this command at any level. So in that case, all the levels will return to the default permissions for this command. So far, we have been talking about granting permissions to levels to operational commands, such as ping, clear, show, and so on. Now we're going to talk about how to grant permissions to configuration commands to levels. In this case, we have to go through three stages. Step number 1, granting permissions to the level to enter configuration mode with this command. Step number 2, granting permission to the level to enter some subconfiguration mode with this command. And step number 3, granting permission to a level to configure specific parameters in subconfiguration mode with this command. We're going to see an example now. In this example, we are going to grant permissions to configure interfaces description. First step, granting permissions to a level to enter configuration mode. So we are going to use the command that we already know, privilege exec, the level number, and then configure terminal. with this configuration, level 11 and above will be able to enter global configuration mode, but they cannot configure anything yet. Step number 2, granting permission to enter a particular sub-configuration mode. In this case, we are going to use the command privilege configure, not privilege exec. Privilege configure, level number, and the particular sub-configuration mode. So with this example, level 11 and above will be able to enter global configuration mode, enter sub-interface mode, but we cannot configure anything yet. For step number 3, we are going to add permissions to modify a certain parameter in sub-configuration mode. This is done on a per feature basis. So we are going to use the command privilege and the name of the feature, the level number, and the actual command that we are providing permissions to. So with this configuration, level 11 and above, we'll have access to enter global configuration mode, interface, sub mode, and configuring the description. And we actually have dozens of features to pick from in order to grant configuration permissions to levels. So we'll have to look for the correct one. For instance, we have router options, we have EIGRP features, IP, for instance, IP SLA options, and so on. After setting up privilege levels, we can start using them, assigning a privilege level to a user with the command username, or defining a default privilege level for a line with this command. So all users logging into that line will get assigned this privilege level, unless these users are logging with a username and a password. In that case, this configuration overrides this one. And users may jump between levels using the command enable and the level number. Okay, let's do our first lab for privilege levels. Let's move across privilege levels. In this case, we are in privilege level 15. So what if we do enable 12? Then we are going to jump to privilege level 12. We can execute ping here. Let's jump to level 8, for instance. And we can also execute ping here. Notice that ping is by default enabled for all levels, and we can jump to lower levels even if lower levels lack a password. However, if I wanted to jump to a higher level, I will not be able to do so unless the target level had a password. In order to jump back to the privilege 15, I could just issue enable. And let's configure passwords for level 4, 8, and 12. So we're going to use the command enable secret and the level number. In this next lab, we are going to grant permissions for level 8 to execute ping. So let's do that. Let's go, and in privilege 15, we are going to configure the command privilege exec, because this is an operational command. In order to grant permissions to operational commands, we're going to use privilege exec. So what happens if I go to privilege level 4? In that case, if I want to execute ping, I cannot do that. So this means that all levels below level 8 are not going to be able to use ping. So let's now jump into level 12. In this case, level 12 is able to execute ping. So all the levels above level 8 will inherit this permission, and they will be able to execute ping. For our final lab, we're going to do the following. Level 4 will be able to clear the ARP cache. Level 8 will be able to do the same, but also resetting interfaces. And level 12 will be able to do whatever level 8 can, plus restarting the device, configuring IP addresses, and seeing the running config. Okay, let's start the lab. We are going to configure everything from level 15. Let's start top to bottom. In this case, This is one way of doing it. So let's configure level 12 permissions. So this will be the permission to restart a device. Next, we are going to follow up with the permission in order to configure IP addresses. This will be the commands. Then the permission to read the running config. This will be the command. And let's go for level 8 now. This will be the configuration to restart an interface. And finally, for level 4, let's grant permission to clear the ARP cache. So the configuration looks like this. Notice that a really bad effect of, for instance, granting level 12 access to the running config is that now level 12 and above have permission to execute show. So levels below level 12 will not get access to the show command. So let's see, for instance, if we go to level 8, we will not have access to the show command. So that is one of the drawbacks of using privilege level. So let's try to fix this. Let's go back to level 15. And so in order to fix this, we could, for instance, issue privilege exec level 1 show. So with that, we will fix this. So we have to keep that in mind when working with privilege levels. Let's wrap up this privilege level part with a summary and some final thoughts. As a summary, remember that for granting operational command permissions, we are going to use privilege exec, and for granting configuration commands permissions, we're going to use privilege configure and privilege and the feature name. There are dozens of these features out there. As a note here, in order to grant permissions to see the running config, we are going to use this command file privilege. And as best practices, always configure harmless commands at lower levels and more impactful commands at higher levels. Keep your lower levels for inexperienced users and your higher levels for more experienced users. As a final thought, privilege levels is a good feature to provide authorization even when AAA servers are not available. But configuring privilege levels is not really intuitive. Better options exist out there, such as RBAC. We're going to talk about RBAC now. Next topic, RBAC. RBAC stands for Role-Based Access Control. It is a per-device local authorization database where selected sets of operational and configurational commands are organized on a per-view basis. So why do we need RBAC? Because we need to guarantee that devices will still be providing authorization features even when the AAA servers are not available. Remember that we need authorization because we need to respond to the question who can execute what in order to improve network security and accountability. So what is a view? A view is a selective set of operational and configuration commands. We can create several views, and there is a particular type of view that we are going to call the root view. That is the place where we are going to configure all other views. In order to configure a view, we are going to go through two steps. First, we are going to configure a password for the view, and then we are going to configure what commands this view has access to. Then you can start using your views. For instance, when creating your local user database, you can assign your users a particular view. Or you can let your users jump between views with the command enable view and the view name. In both cases, the user must know the view password. There are two approaches in order to configure views. With the first approach, we're going to start with a view that is actually empty, and we are going to include commands into it. And with the second approach, we're going to start with a view that has access to all commands, and we are going to exclude commands from it. In both cases, we can define commands that are exclusive to this view. With RBAC, we have another types of views known as super views. A super view is a view that happens to contain older views. So in this example, this view contains the advanced view and the juniors view. We cannot add more commands to super views. There is another type of view for RBAC that is known as the lawful intercept view. This only applies for service providers. Just a note here, RBAC and Radius can integrate with each other using what in Radius is known as the vendor-specific attribute. This is the attribute that is going to be used. Only one view per user is supported with this solution. Let's see how to configure RBAC. First step will be enabling AAA with the command AAA new model. Second step will be entering into root view mode. In order to do so, we need to enter the command enable view. We are going to have to enter the enable password here, and then we are going to enter configure terminal. That will lead us to step number 3, where we can create, edit, or delete views. In order to create a view with no commands, we are going to use the command parser view and the view name. In order to create a view with all the commands, we are going to use the command parser view, the view name inclusive. In order to create a super view, we are going to use the command parser view, the view name super view. And in order to delete a view, we are going to use the command no parser view and the view name. And in order to edit a view, we are going to use the command parser view and the view name. This will lead us to step number 4, where we are in view mode, where we can use the command secret to assign a password to the view. Then we are going to use 3 variants of the same command: commands exec, commands configure, and commands feature name, in order to exclude commands from the view, include commands into the view, or include exclusive commands into the view. These commands cannot be granted to other views. And now for super views only, we can add views with the command view and view name. Finally, in order to use a view, we need to enter the command enable view and the view name. When working with views, we are going to make a heavy use of this particular command. Let's see how to use it. When granting permissions to operational commands such as ping, clear, reload, show, and so on, we are going to use commands exec. For instance, commands exec include ping. Now, in order to grant permissions to configure commands, we go through 3 stages. First, we allow this view to enter the global configuration mode with this command. Then we allow this view to enter a particular configuration submode with commands configure, not commands exec, command configure. And then we grant this view permissions to the actual configuration command with the command commands feature name. There are dozens of these features names. As an example, in order to let a view change the description of interfaces, these will be the commands. This is how to configure lawful intercept views. However, remember that this is only needed if you are managing a service provider network. Okay, let's design a lab for RBAC. In this case, we need a junior team that can execute clear ARP cache and can change description of interfaces. Then we have an advanced team that can do whatever juniors can, plus resetting interfaces. And we have an admin team that can do whatever advanced engineers can do, plus restarting the device, configuring interfaces, IP addresses, and seeing the running config. Okay, let's start configuring this lab. In order to configure views and working with views, we will need to enter into root view mode. So we will need to issue enable view. At this point, we cannot do it because we need to enable AAA. So let's enable AAA. And then we can enter root view mode. We will need to provide the enable password, configure terminal, and now we can create the first view. Let's start with the junior view. We are going to provide this view with a password, with the command secret. We are going to let it clear the cache, the ARP cache, and we are going to let it change the description of interfaces. Now we are going to create the advanced view. In this case, we are also going to assign this view a password with the command secret. We are going to let it clear the ARP cache and configure the description of interfaces and reset interfaces. Finally, we are going to create the admin view, where we are going to add a password with the command secret. We are going to let it clear the ARP cache, modify interfaces description, reset interfaces, modify IP addressing, restarting the device, and this will be able to see the running configuration. As a last topic, we're going to talk about line security. First of all, regarding authentication, the best way to authenticate users to our devices is using AAA servers. If we don't have that, the next best thing is using a local user database. And this recommended way will be using line passwords. Now, regarding the auxiliary port, we should issue this command noexec in order to disable it. Back in the day, we would use auxiliary ports to connect modems to it, so we had an alternative way to reach our device remotely. Nowadays, nobody uses that, so we should disable it altogether with noexec. Regarding the console, we should use this command, transport input known, so no one is going to telnet to us through the console. Most of the time, this command exists by default in recent iOSs, so we don't have to enter it manually. And this was a thing back in the day when people had out-of-band networks connected to consoles. Now, regarding BTYs, we should always use access control is using the command access group, and we should avoid telnet at all costs, so we should at least support secure shell with transport input secure shell. Now, there are some exec security commands. Remember that Cisco called exec to the environment where that we use in order to enter commands. Other people call this just a shell. So we might want to log out idle users with the exec timeout command. We may use also the absolute timeout to log out all users after they have been online for some time, regardless of whether they are busy or idle. And we might use logout warning in order to send a preventive message to users before logging them out.